Hello, welcome to the live stream. Just finishing it. All right, headphones, cool. I think we're good. So, welcome to this. This is Code with Me. I do this every Tuesday at 10 a.m. Eastern, and today we are doing. We're going to be focusing on USD and specifically USD preview surface material. And this is a question that came up during developer office hour this past Friday, and it was a pretty good question. There are examples here of using USD preview surface in simple shading tutorial, and also the specification has a USDA example here. But I don't think I found a full example using all of the nodes. Just double check here one more time. So here's a sample. Yeah, so there's no full sample using that. So the question was mostly about USD transform 2D, but we can go ahead and build an example using all of the nodes, which is I think four core nodes for this. So that's what we're going to do. We're going to be writing a Python script to generate this, very similar to the simple shading USD tutorial, and hopefully that'll help developers with understanding how to use the API to do this. So if you are here, let me know in the chat and we will get started. Welcome Funky Boy and Data Juggler. And then for today, I'm going to be using this material from Ambient CG, which is pretty cool. It's a CC0 material, so totally free to use. And if you can give attribution, that's not required, but nice to do. And one of the cool things that I learned today is that they actually, when you download one of these materials, they actually generate a USDA and USDC file for the material. So you could actually just reference this into your stage and you get a preview surface material. So let's try that just to see what that looks like. I think these are identical, but there's a material and all of the nodes. And then you'd say, well, your job is done. But it doesn't look like they used the they're using the primvar reader. The only node that they're missing is the transform 2D, which is specifically the one that we need to figure out here today. So so let's go ahead and get started. Now we're going to go to, I've got my code set up here. This is all connected. And we can really just go follow the tutorial to start. I'll have it generates a plane, and that should give us a good starting point. So here we go. So let's take a look here. We're gonna mostly everything that I show will work anywhere where you're using USD. The only thing that's going to be different here is I want to get the active stage from Omniverse as I'm working instead of creating a new stage. So for that, I'm just going to do OmniUSD get context get stage, and that's just for me. That way I can preview things immediately in Omniverse code right now. We can set the y-axis too. Why not? Access. USD okay. We won't deal with model API right now. And yeah, I guess I need to make that plain. So let me move this like that. I need to import USD and we're just going to do the mesh. We don't need to worry about doing a proper configuration here. So billboard is equal to USD mesh define stage, and we're going to put ours under world board. Feel free to ask any questions as I go along. We haven't gotten into, we're not doing anything related to materials right now, and we're just going to generate a plane. So first thing we do is create a points attribute on that mesh, and we're going to set up, we're going to do ours square. So the only thing that I'll match is the positives and negatives here. So it's going to be negative 100 in X and Y, and 0, and positive, negative, and what is this doing? That's fine. I'll stick with it. Positive, positive, and negative, positive. Negative, positive. Okay, so all that's doing is defining the vertices for our plane. And we have four points, right? Then we're gonna create a face. We're gonna define a face based off of these vertices. And we're gonna say there is one face because there's one item in the array, and it has four vertices. So this is all about USD understanding how these points connect together to create faces. And then the next piece of this is the vertex indices attribute, which basically says, okay, so let me write it out and then we'll talk about it. Basically what this is going to say is, okay, there is, for the first face in this mesh, there are 4 points. So it looks into the vertex face vertex indices array, and it grabs the first 4 indices. And then from there, based off of those indices, it goes into this points array and grabs each of those points. So in this case, it's really simple. We're just saying use all 4 points to create one face, and using the vertices in those positions. But if you had a really complex mesh, doing this will help you reuse vertices so that you can reduce your data size, so that if 2 faces are touching each other, these points here would be able to be shared, and you can achieve that using the vertex face counts, the vertex counts, face vertex counts, and the indices to say which ones get repeated. You'd see potentially these indices repeated for every time that vertex is shared. We can create an extent. This is just extra data that USD uses to understand where understand the bounding box of this object. And put to just a min and max range here. The min and then max. And Funky Boy is asking why not create, let me get this up here. Why not create a plain prim instead? So there is a shape called plane, right? No, there isn't. So first of all, I wouldn't use a shape even if there was a plain shape, because shapes don't have UVs, and I need that for the material. Second, I could use this command, the command that generates this plane. And Funky Boy's right. He's like, dude, you could do this in like 2 lines of code. But I wanted to just do the full vanilla USD for this. So that way I can use this code, not just in Omniverse, but anywhere. But yeah, that's the motivation for this here. So let's go back here and here. So we got that. Okay, and now we're going to set up the UVs for this. I'm going to use USD Primvars API. So we're going to use a specific API for this. We're giving it a mesh object, and you can do this without the API, but it is pretty convenient to use this. ST is another name for UV, and the default name that most folks use for the UV attribute on meshes. So for greater portability, you're going to have a better time naming your UVs based off of what folks are expecting. 2F array. And all we're saying here is that it's an array where it's stating its data type. It's a two item vector, U and V, right? And it's an array since we want a list of UVs that this makes up. I need to import SDF. And then we're saying that it varies per that the values are varying, that per vertex, the render should expect that the UVs are going to vary across the faces. Cool. And then we've created that primvar attribute, and now we just need to set the data. So this is just a very basic, we're doing a plane to keep ourselves sane. So the UVs are very simple, right? It's just each corner of the plane. Okay, let's go ahead and run that. It's a good stopping point. I'm going to run that, and I must have made a mistake here. Value type. I think that's supposed to be singular. Yeah, that was my bad. Not a. I can copy that. All right, so we got a plane, and I think that's the front side, but we'll find out. I was thinking about laying it flat just to be certain right off the bat. We can also make this single-sided to know for sure. But there's a couple of settings that I need to set for that, so I'm not going to deal with it. Cool. So there's our extent. there's our points. And we haven't done any normals. We don't need to explicitly define that. Here's our indices and counts. And where are our UVs? So that I think is only in the, it's not shown here. It's going to be shown in the raw USD. And there's the primvars ST with our UVs. So our mesh is set. Very long step just to create a mesh, just a plane. But it's good to learn that stuff as well, especially if you're going to be translating meshes from one application to another. We need that. So, good. Let's carry on. I don't need this anymore. We have our billboard. Now we can make material. Yay. And for that, we need to import USD shade. I'm not sure if I'm going to use USD model at all here, but rid of it for now. And we're going to define a new material, same way that we did the mesh, except we're using this class here. Stage and where we want it. We're gonna, yeah, this is fine. I was gonna set up a looks folder and all that, look scope, but preview material. And we'll go ahead and set up the shader. So this material without anything and without any shader defined doesn't do anything. So let's also define the shader while we're at it. And you can think of a material as a node graph, and we would put the shaders inside of the, as children of the material. So we're going to do and PR shader. Going to create an ID. This tells you USD and the render, the render, what type of shader it is. So for the 4 core nodes, you just give it the name of the ID of the shader, and USD and the renders will know because those are the core definitions, and we're good. You can extend USD to add new definitions for different renders. That's totally fine. And you would you would use those new IDs that you define to create those shaders. Alternatively, in Omniverse, we do materials using assets. So let's see. So the way that Omniverse defines, and this is both ways are defined in USD. They're both valid. So my bad, the shader. There we go. So USD. So you can see here that there's 2 different implementation sources. ID is the one that we're following the tutorial. Source asset is the one that we use for MDLs. And so once you've set that to source asset, you can then specify source asset attribute pointing to an MDL file. And then there's also a sub-identifier attribute, which is basically saying, because MDLs can have multiple shaders defined inside of them, you can select which shader you want from that file using that attribute. All right. So just a little detour there. Okay, so we're creating it by ID. This is This is a mess. I should have just stuck with following the tutorial to the T. Uh, Now I'm going to be fixing that throughout. We're going to set up roughness for this material. Float attribute. And a 0.4. Do the same thing for metallic. So how do we know? How do I know what I'm putting here? This is following the spec. So if I look at preview surface, it tells me that these are all the attributes that are defined for a USD preview surface. So metallic is a float, roughness is a float. These are the default values. If I don't set them, it's going to use that. So that's what we're doing. Good. Go back here. Okay. And let's wire up. This is not going to make much sense, but the good thing about doing this with the GUI next to us is that it'll help us understand what is going on here. So now we're creating a surface output on the material. And for me, until I actually visualize this, it doesn't make much sense. We're using the connectable API, and we're gonna connect the shader to the surface. Okay, let's run that and see what it did. I'm just going to delete that billboards, and we'll recreate it right now when we run this. Okay, so material prim, shader prim. It's by default. I noticed that I didn't set the implementation source attribute. That's the default is ID, so we leverage that. And then I set the text. What is this? A token for USD preview surface. And then here are our two inputs. And then what was all that bit about connectable API? All that is doing is it is connecting. The material has this outputs surface attribute, and that it has these three. And it can output displacement, surface, and volume. And so the surface material is being defined by this shader. And all we're saying is take the output of this of this shader and connect it to the output surface of this material. And so let's can we visualize this in? Yeah, we can visualize this in a graph here. So that's what it's doing. Okay. So that's our node graph, right? This is the material, and then everything else. So we're going to start building out our graph here to connect to that output. And you can see we have similar things in Maya or Blender. You have some. Well, it's not quite similar. Yeah, I guess they do have. It's typically some Uber shader with a bunch of connections, and then that connects to some material. I forget what they call them in Maya. But yes. So let's continue. Adding texture. Oh, and I just wanted to see I want to play around with this a little bit here, but environments, my friends, the sunflowers, and if I change this to 1, metallic material. Hard to tell, but that should be working. So let us move on. Mostly just, that was just something to check out. Great. Now we're going to do all of this business. So this is where we incorporate node number 2. So we're going to do world preview material. Texture is fine. Actually, node number 2 and 3 potentially. Yeah, node number 2 and 3. So here is our ST reader. This is another node. And all this is doing is reading the UVs from the mesh and passing them to the material. Yes, this is a tutorial from Pixar. We'll put it in the chat. Thanks for bringing that up. And also the USD preview surface specification. So how are we doing on time? We're halfway. Okay. So this is the name of the UV reader. Kind of a mouthful, but there it is. And then we're defining a texture sampler, right? This is going to, we give it a file to we give it a path to an image file. It'll read the image, and then based off of the UVs, it'll sample the image and assign those colors to the right part of the mesh. So for the UV reader, it looks like we don't need to set any attributes, but I may be wrong. That might be later. For this one, here's the ID for the UV texture. We are connecting the UV texture has an input called ST, and we're connecting from the reader. It has an output called result, and we're connecting it to this input on the UV texture. So we're saying when you read the UVs using this shader, feed those UVs to the texture sampler into this input, and we'll visualize that in the node graph. And then once it has read the color, it then outputs RGB values for that texture. And diffuse color, what is this? And then we're connecting on the PBR shader. There is a diffuse color attribute, and we're connecting the result from the texture into the diffuse color attribute of the shader. So we're saying for the diffuse color of this PBR shader, use the texture. Before it would just use whatever color I fed it. So before we even connect the attribute, let's look at color So we're gonna create the diffuse color attribute here, and I'm gonna set it to red. And I will fix it to a 0, to a 1. Okay, so if I run this again, I'm gonna delete this stuff. Run selected code. I got an error. It wants a vector 3. I gave it an array, so this actually needs to be parentheses here. I think that'll translate it correctly. So if you use the right Python data type, it will automatically convert it to the USD data type for when you're setting attributes. So I think in this case it wants a tuple. So there we go. And it set it here. I must have something wrong here. It did set the color. It's just, oh, because I haven't bound the material. That's weird that we've gotten this far and we haven't bound the material. So and that's why the metallic wasn't working. And in Omniverse, I can just drag it onto the mesh and it'll automatically assign. But now, there we go. That's metallic, right? So we'll get there. Let's follow the tutorial as we go. But I just wanted to show you can set a constant color this way. But now we're going to set it up with the texture. So good. So we can use the same create input, or we could get the input. If it already exists, it'll just get it. And so we just need to set the right path for the file. So let me grab that. If you're new to Python, this uses a raw string, so I can use the backslashes here, which normally Python would have some trouble with. But that way I can use the Windows way. It's probably a better idea to change those to forward slashes. I don't remember what happens if you put the USD automatically convert it. Let's find out. Okay. Run. No errors. Let's see what it did with the diffuse texture. So it's still doing backslashes. I don't know if this will cause problems when you go to, say, a Linux system. But I should be able now to assign this, and hey, looks great. All right, still not PBR, or not good looking PBR. So let's come over here, and just to be on the safe side, we will convert these to forward slashes. All right. Okay, so where does that leave us for the tutorial? Let's visualize that graph, right? Here we are. So here is this UV texture. Sorry, what am I looking at? Did it not create the reader? Or maybe we don't visualize that? It's there. I don't know why we don't show that node. All right, I'll have to look into that. But the node is there. I'm connecting to it. You can see here that the ST reader output result is connecting to the ST here on the diffuse texture, right? This is the ST input, and this equals means that it's connected to the ST reader outputs result. So there should be another node here connecting to this one. Then the RGB output from this texture sampler is going into the diffuse color of the shader. And then we saw the rest. All right. Yeah, there's no, now that I think about it, there's no, we don't currently have a definition for that reader, the UV reader. We have a different primvar lookup node. But it is there. We could look at the USDA and see that. Okay. So okay, so now this is just more of a convenience thing, is that you can have you can define on here, we're defining a primvar name for the UVs, and we're setting it to ST, and then we're feeding that to the UV reader. Know what name of the UVs are, because you can have multiple UV sets, and you can access them by name. So let's go ahead and see what that looks like. And in this case, it just worked because we're using that default UV name. But let's see what this looks like. Okay. If we look at this material now, we've defined this primvar name, and we've named it ST, and then we're passing that through. Did we not connect that yet? Let me check, double check here. Yeah, we've connected var name on the reader. Yeah. So again, we're not going to be able to see that node, unfortunately. But it is connecting to the ST reader. Let's go ahead and open that up and see what that USDA looks like. So here is that input connection on the material that we've created. And then that is plugging into, that's why I messed up. It's over here. So that, yeah, my bad. Let's fix this. Okay, so this at least the prim should show up. I don't remember if did I get that right? ST reader. What happened is bad copy paste. Let's go ahead and check that out now. There it is. So there's the shader. What happens if we look at this now? Oops. We want to look at this one. There we go. Sorry about that. So this is coming from the material. It's the name of the UV. It's connecting to this var name input, and then outputting to the ST. So what this allows you to do is that if you had, for example, you exported out of Blender or Maya, I don't remember which one calls their UV set UV map. You could, your UV set could still be named UV map. You just set the value here to UV map, and when it's bound to a mesh that's using that UV map UV set, it would be able to find it and feed it into the texture samplers, which are the ones that care about those UVs. So good thing to keep in mind, UV set names. Okay. Finally, we're going to bind the material to the mesh. So billboard, we're going to apply a material binding API, schema, which now is a, I don't remember starting which version of USD, but the newer versions will actually require your material bindings will not work unless you specifically set the API in this way. And then we finally bind the material, the mesh. We bind the material to the mesh. So let's go ahead and run that, and we will look at that. Clear this out. Okay. So now if we look at the billboard, you can see that now it applied automatically. I didn't have to drag it in. And if we look here to material binding, it's a relationship that just points to the material. So the renderer will, when it goes to render that mesh, it'll check to see if it has any bound material. It could be on the bound material could be on a parent of this billboard mesh, and it would compute the bound material, and it'll use that material for rendering the mesh. So I can remove it, add it, and that's it. Hey Nandu, welcome. So now we don't need to save because we're doing this in Omniverse. And at this point, the tutorial's done. But we need to do the USD. We want to do USD transform 2D. We want to be able to move the basically scale or move the texture around. So let's come back over here and let's look at that. So now, based off of what we learned from that tutorial, we should be able to implement a USD transform 2D node. And this is the ID, and it takes an input. This would be the UVs, right? The float2 primvar reader. And then you can we can set the rotation, scale, translation, and then that's going to output, again, float2. That's going to output the UVs, and we're going to connect that to our shader. So let's go ahead and do that. And if there's time, we'll set up the other textures for normal mapping and roughness and all that. But I want to make sure that in the 15 minutes that we have, that we cover this last node. Okay. So I guess we can do this up here. It doesn't matter the order. We can bind and then continue to work on this material after the binding. But just to follow this pattern, I'm going to build this up here. And I think we can put that together. And we'll do it here, right? So this is our texture sampler. And we're going to do form 2D is equal to and potentially we only need one of these for all of our different textures, right? Because if you're scaling or rotating the diffuse, you probably want to rotate and scale the normal and the roughness all the same. So I can just name it generically transform 2D and you reuse it for all the other ones. Then we need to set the and we create the ID on this one, which will be USD transform 2D. And then input, let's do we're going to create an input called in. Doing this on the transform 2D. And it's going to take as input the result, right? So actually that's already done. Great. And then we'll create these other inputs just so that we have something to play with. So maybe this one's a good one. And the first one looks like it's float, float 2, float 2. So the first one is rotation. So we put this on the right shader. Second one is scale. And the last one is translation. And this will be a float 2 and a float 2. And now, just a moment. Sorry. Preschooler is done with school and now he's here. So usually I'd be streaming while he's in school, but now he can raid my office. So where were we? Yeah, so we're creating those inputs and we've already created the input connection there. So now we just need to do the result from this one. So here, where we're connecting result from ST reader to the ST, we just need to connect transform 2D now. And I've never done this before, so hopefully it works. Let's try it. What did we do? All right, let's open this. So we have preview material, yeah, just the name, to ST reader, to the transform in, the result out to. So if I did my job right, no. Not quite, eh? What is this? Let's go ahead and, as a sanity here, I'm going to scale this up to, and I'm going to rotate to 45. Let's save this, open it in USD view, and make sure that I didn't run into some sort of bug. I think I did everything right. Let's see. I'm launching USD view now. And we're going to open up Transform 2D. I saved it in my downloads. Hey, look at that. It did work. So those are the transformations that I did. I'd wonder, I thought it would scale up, not down, when I did a value of 2. But it did do some rotation there. So let's undo the scale. And then save this, reopen stage. There's a 45-degree rotation. And if I set this back to 0, there we go. So it looks like, it looks like it was rotating from that corner. We'll have to take another look here. But if I do 0.5, does that mean that it's going to scale it up? Because that seems counterintuitive. I need to look at the spec again. That does look bigger, yeah. Most definitely. So let's look at that spec. See what the heck's going on here. Scale around the origin to be applied to all components of the data. Translation, and then rotation counterclockwise in degrees around the origin to be applied to all components of the data. So if I multiply by 2, yeah, if I multiply by 2, then it's a bit counterintuitive, right? I multiply by 2, then the UVs would get bigger, and so the texture would get smaller. So this is correct. And then the rotation also doesn't seem very transformations done in then scale, then rotation, and then translation. So I did the rotation and then did translation. Save. Yeah, and this is rotating about that point there. I'm not sure how that's useful, or I guess you have to. You might need to queue some of these up. So you probably would do. Would that work if you did a translation and then you did a rotation? Because ultimately, what I want is for it to rotate about and scale about the center. That seems intuitive to me based off of how other applications would do their texture scaling. And let me open this here. Thanks for coming, Data Juggler. So it looks like everything's working. I was silly and I was opening in USD view, but this should also be reflected here when I switch to Pixar Storm. So I'll need to see where we're at with this in Omniverse. I thought this was addressed, and maybe it's coming with the next release. But yeah. So if we did, can I do this interactively to not have to write a bunch of code? So we have 4 minutes left. I may come back on and do a second pass at this just to tie this all up. But But the code is there. We do have a working. We've used all the nodes. We've used them correctly, and so I'll be sharing this code on my Code with Me repository, which I can link to right now. So this script will be in there in the scripts folder, and so we're good there. As we saw, not a lot of people are using this node, but it is there. At least I haven't, from folks that are providing assets, I haven't really seen them using that. But what I wanted to do is see if I were to chain these a bit. There we go. And this one's a revision. I've got an error here. Let's save this and reopen it. Just sure we're in good shape here. Nope. Now we're good. I think. I must have done something I wasn't happy with. That seems like it should be legit. Okay, so if I translate this 0.5, 0.5, and not do anything else, and we save this, can we edit UV in Omniverse, or do we have to do it? We don't have a UV editor currently in Omniverse. The only thing you could do is do it programmatically, right? There is we have the array of UVs you can write code to. If you just wanted to scale it without the transform node, you could totally just, take this array and multiply every value by 2, and you've scaled it up to. Okay. So let's reopen. So I think this should be, no. Yeah, I don't know about that. I thought that should be a valid configuration here. But it really doesn't like that. So I'll need to find out about that. Disconnect. So there's that. And it looks like the Transform 2D doesn't even have any notion of repeating textures. Where were we here? Yeah, okay, so this is exactly what I should have read this note here. So it transforms texture coordinates, not the textures themselves. So to get the effect of moving, resizing, and rotating an image being applied to its surface, one must apply the inverse transformation of how you expect the image to move. So that's where what happened with the scaling, right? If I wanted to scale the texture up, I actually need to do a smaller number for the UVs. So that explains that, but I'm not sure how to use rotation and scale in a way that's intuitive and the way that I would in a DCC, which would be about the center of the UV space. All right, we'll see if I can do a follow-up on this. I'm also surprised. It seems like this should be supported as well, the chaining of these nodes. But that wasn't happy either. So yes, we'll come back to this. See, so ideally, potentially if I could chain the nodes, then what I would do is translate to the origin, rotate, and then translate back. See what happened here. Try it again, but I really didn't like it. Yeah. Default scale is 1, right? Yeah. Let's look at the example here. Actually, right, there's no example for this one. All right. 0.5, 45, negative. Yeah, I'll have a closer look. All right. Any questions before we take off? All right. Well, I hope you guys have a great week. And Friday, I have the developer office hour, and maybe we'll just wrap this up there. Hopefully, I'll have an answer for that. And that's Fridays at 10 a.m. Eastern as well. So thank you for coming, and I'll see you around.